Hi guys, I'm here to talk about finding the sides of a right-angled triangle using trigonometry. So let's get started. First, we need to identify the sides of the right triangle in terms of the acute angle given. So here we have angle A, and right across from this angle, we are going to identify that as our opposite side. And then across from our right angle, we know that that is called the hypotenuse. And then we have one leftover side that we have to identify, and we're always going to call that leftover side the adjacent side. It's adjacent to the angle that's given. Now, let me give you another example. So if we have another triangle, and now we have angle A in this position, now the side across from this angle is going to be the opposite side. Then we're going to go ahead and identify our hypotenuse across from that right angle, and then the leftover side is now the adjacent side. So you will see that your opposite and adjacent side is going to change depending on the location of that acute angle. Okay, so once you've identified your opposite, adjacent, and hypotenuse, now I want you to think about the special triangles that we've done so far. We've done the 30, 60, 90 triangle, the 45, 45, 90 triangle. So let's take our 30, 60, 90 triangle. We have our 30-degree angle at the top, our 60-degree angle at the bottom. Our hypotenuse is 24, and then it's going to be our job to find this short leg. So think about what we do. We know that we have to find the value of x, and we know that the hypotenuse is twice the short leg. So if the hypotenuse is 24, then we know that x would have to be 12. So then if we take 12 and we divide that by 24, we're going to wind up with 0.5. Now, look at where the 30-degree angle is. Here we have x, which is our opposite side, and 8, and our hypotenuse, which is 24. So 12 divided by 24 is 0.5. That's the opposite side divided by the hypotenuse. So we have a special name for that. Whenever we have our opposite side and we divide it by the hypotenuse, it's called the sine ratio. So for every angle, the sides have a given ratio, but there are way too many to remember. We know 30, 60, 90 and 45, 45, 90. So let me just show you what I mean by that example. So here we had our 30-degree angle, and the side across from it is our opposite side, and we divide it by the hypotenuse. We call that the sine ratio. It's going to show up here in the chart, and you're going to see that it's 0.5. So we knew from our previous example that 12 divided by 24 gives us 0.5. So now look at this. We can find out the ratio of any side that has the opposite side and the hypotenuse, because we have this chart here. So if we have a 20-degree angle, the side across from the 20-degree angle divided by the hypotenuse is this number. But luckily we don't have to remember them all. These are all stored in our calculator. So again, the sine ratio is the opposite side divided by the hypotenuse. So let's take a look at these other two. So the sine is opposite across from the hypotenuse. The adjacent side, when we divide that by the hypotenuse, it's something called cosine. And then our opposite side divided by the adjacent side, that is our tangent ratio. So we have a special way that we can remember these. So, ka, toa. So S stands for sine. The sine is the opposite over the hypotenuse. The ka, cosine, is adjacent over hypotenuse. And toa, the T is the tangent, is the opposite side over the adjacent. So let me show you how this is going to work out with problems. So we have to find the value of x in the following right triangles. Let's take this green one. First of all, I have my acute angle here, my 16 degrees. The side across from it, the opposite side. The side across from our 90-degree angle, the hypotenuse. And then that leftover side is our adjacent side. you're going to notice that you don't have any information here with the adjacent side. So I'm going to go ahead and cross it out. That leaves me with the opposite side and the hypotenuse. So you're going to say to yourself or write down so ka toa. Now, O, so that's using the so part. That is the, which ratio do you think? Yep, it's the sine ratio. So it's the sine, then use the angle, 16 degrees, is equal to, so it's opposite over hypotenuse. I'm going to go ahead and fill that in my equation, x over 25. Now all I have to do is solve for x. So I'm going to get rid of this 25. And by multiplying both sides, I'm going to have the 25 times by the sine of 16 is x. All we have to do is just plug that into our calculators. So 25 sine 16 will give us 6.889. Now make sure that your calculator is set to degrees. If it's set to radians, you get a completely different answer. Radians, we're going to do that in Algebra 2, but right now in geometry, we're always using degrees. Okay, so our next example in our blue triangle here. So here I have my 17-degree angle. Across from it is my opposite side. Then I'm going to identify the side across from the right angle, the hypotenuse, which leaves me with the adjacent side. So nothing by the hypotenuse. I'm going to X it out. So now I have the opposite side and the adjacent side. So you're going to think so ka toa. So oa, tangent, that's the one we're going to use. So the tangent, then fill in the angle, 17 degrees is equal to, so oa, opposite over adjacent, I'm going to fill in my 42 over x. Now I want to solve for x, but this time the x is on the denominator. So we could multiply both sides by x to get it right back here on the numerator. And then we could divide by the tan of 17. But how about we do it in one move? We just take the x and the tan of 17 and we just switch the two. And then we're going to have x is equal to 42 divided by the tan of 17. Put that into the calculator. Here I'm rounding it to 2 decimal places. Go ahead and pause the video, put it into your calculator, and hopefully you should get 137.38. Okay, one more. So my yellow triangle. Here I have a 68-degree angle. Let me get my, there we go, 68-degree acute angle. So across from it, opposite side, across from the 90 degrees, the hypotenuse, leftover side is the adjacent. This time I'm going to go ahead and get rid of my opposite side. Leaves me with the adjacent side and the hypotenuse. So ka toa, the ka part stands for cosine. So that is what I'm using. So it's the cosine of 68 degrees is equal to adjacent over hypotenuse. Go ahead and fill the x over 125. So now I need to solve for x. I'm going to get rid of my 125. So I'm multiplying both sides. So 125 times by the cosine of 68 degrees is equal to x. Pause the video if you have to. Put it into your calculators. You should get that it's approximately equal to 46.82. Again, I'm rounding these to 2 decimal places. Okay, well, I hope that helps you. Thank you for watching, and I hope this helps you use trigonometry to find the lengths of the sides of a right triangle. Thank you. Bye-bye.